A major shift is underway in the automotive industry. One of the most influential and rapidly growing electric vehicle manufacturers in the world has made a surprising and powerful claim. Electric SUVs, specifically mid-size models, could soon be available for just $7,000. This isn't speculation from fringe commentators or futurists. It's coming directly from a senior executive inside a global EV powerhouse with operations and sales extending across multiple continents. Today, the idea of buying a brand new electric SUV for only $7,000 seems almost absurd. Typically, this kind of budget might only be enough to purchase a used gasoline-powered vehicle with over 200,000 miles on it, and even that would likely be pushing the limits of reliability. Most new mid-sized electric SUVs are priced anywhere from $30,000 to $50,000 depending on the brand and features. At face value, imagining that a new, reasonably sized EV could retail for just a fraction of that cost seems almost impossible. Yet the auto executive suggests otherwise, arguing that the industry is on the brink of a fundamental transformation, one that will make these prices not only possible, but economically viable. According to the executive, this transformation will begin in China, the epicenter of global EV manufacturing and innovation. The Chinese market is already home to the most aggressive price wars in the electric vehicle space, and the competition there is forcing companies to innovate, reduce costs at an unprecedented pace. As these advancements mature and gain traction, the resulting price drops are expected to spread beyond China into global markets. What begins in Shenzhen and Shanghai may soon echo across showrooms in Europe, Southeast Asia, and eventually even North America. The underlying mechanism behind this dramatic price drop is multifaceted. One of the most critical components of this shift lies in simple economics. When manufacturers double their production output, the cost to produce each unit generally drops by about 20%. This principle, known as the experience curve or learning rate, applies strongly to the automotive sector. As electric vehicle production scales up from tens of millions of units globally to potentially 40 or even 60 million units in the coming years, the per-unit costs could decrease significantly. If the cost of manufacturing each vehicle is reduced by 20% every time the total output doubles, then a compound effect occurs, rapidly driving prices downward. But economies of scale are only part of the story. Technological advancements are playing an even more crucial role. Manufacturing plants that once relied on large human workforces are increasingly turning to robotics and artificial intelligence. Labor, especially skilled labor, is one of the most expensive aspects of car manufacturing. If robots can now perform the same task with greater speed and precision, then costs can be slashed dramatically. AI is also being used in design, supply chain optimization, and quality control, removing inefficiencies that used to be built into the process. Fully automated or near-automated factories are now a realistic goal, and their widespread adoption is only a matter of time. Another breakthrough that is reshaping how vehicles are built is gigacasting. Traditional automotive manufacturing requires assembling a car from hundreds or even thousands of individual components, each one requiring its own tooling, handling, and inspection. With gigacasting, major structural elements of the car, such as the entire underbody, are cast in one or two large sections. This dramatically reduces the number of parts and eliminates the need for extensive welding and joining processes. As a result, production is faster, simpler, and far more cost-effective. What used to take dozens of steps now takes a handful, and each simplification translates into savings for both manufacturers and consumers. No discussion of EV cost reduction would be complete without examining battery technology, which remains the single most expensive component of any electric vehicle. Fortunately, battery costs have been in steady decline. 10 years ago, battery prices were high enough to prevent most EVs from achieving price parity with their gasoline-powered counterparts. Today, lithium iron phosphate (LFP) batteries, known for their durability and cost-effectiveness, have dropped to around $55 per kilowatt hour. That's a staggering reduction of over 90% from their peak levels. And the trend is continuing. On the horizon is an even more radical development: sodium-ion batteries. These batteries replace expensive materials like lithium and cobalt with sodium, which is far more abundant and less costly. Experts believe sodium-ion battery prices could fall as low as $10 per kilowatt hour in the near future. If such forecasts materialize, the impact on EV pricing would be profound. Suddenly, battery packs that once cost thousands of dollars could be built for just a few hundred. Sodium-ion batteries also have the advantage of simplifying battery management systems and thermal regulation, further contributing to cost reductions. While their energy density is not yet on par with lithium-ion batteries, rapid advancements are narrowing the gap. As energy density improves across all battery types, automakers will be able to design vehicles with smaller, lighter battery packs that still offer substantial driving range. Smaller batteries mean less material usage, less structural support, and ultimately lower vehicle weights. This reduction in complexity and weight also translates to further savings in manufacturing. The structure of the battery pack itself is evolving as well. Some automakers are already integrating the battery pack into the frame of the vehicle, a technique known as a structural battery pack. This allows for further reductions in material use, weight, and assembly time. By making the battery a fundamental part of the car's chassis, manufacturers eliminate redundant components and optimize the design for both safety and efficiency. These advancements are occurring at a time when traditional internal combustion engine ICE vehicles are becoming more expensive to produce. As regulations around emissions tighten and engineering complexity increases, ICE vehicle costs are not decreasing. Moreover, ICE vehicles cannot take advantage of gigacasting, battery pack integration, or advances in AI-driven manufacturing to the same extent that EVs can. They are constrained by legacy technologies and architectures, while EVs are designed from the ground up to benefit from these innovations. China provides a clear example of this trend. Over 50% of all new vehicles sold in China today are electric. In many cases, EVs in China are already cheaper than ICE vehicles. Statistics indicate that 2/3 of the time, an electric car is less expensive than a gasoline-powered alternative. Moreover, EV prices in China continue to decline almost monthly, while ICE vehicles remain static or increase in cost. This market behavior supports the argument that electric vehicles are not just catching up, they are overtaking ICE vehicles in terms of value and affordability. Given all these factors, the idea of a $7,000 mid-sized electric SUV becomes less implausible. Consider the combined effect of doubling global EV production, replacing human workers with robotics and AI, using gigacasting to simplify car construction, adopting sodium-ion batteries for dramatically cheaper energy storage, and integrating battery packs into the vehicle structure. Each of these developments contributes a measurable decrease in cost. Together, they create a compounding effect that could drive vehicle prices to levels previously thought impossible. There's also the feedback loop created by falling prices. As EVs become cheaper, more consumers can afford them. As more people buy EVs, production scales up. As production increases, costs go down further, leading to even lower prices and greater adoption. This virtuous cycle resembles what happened in the consumer electronics industry, where items like smartphones and laptops once considered luxury products are now everyday commodities. Legacy automakers face a significant challenge in adapting to this rapidly changing environment. Companies heavily invested in internal combustion engine technologies may find themselves at a disadvantage. Their factories, supply chains, and product lines are not optimized for the kind of radical cost reductions being achieved in the EV sector. Some automakers still publicly claim that EVs will never represent more than 30% of global car sales. Yet current trends suggest that this prediction may already be outdated. The automotive industry is undergoing a transformation unlike anything it has seen in over a century. Electric vehicles are not just becoming more popular, they are becoming more affordable, more practical, and more accessible to the average consumer. With innovations in battery technology, manufacturing techniques, and production scale, the dream of a $7,000 electric SUV is no longer fantasy. It is a glimpse into a very near future. The momentum behind electric vehicles cannot be stopped. It is powered not just by environmental concerns, but by the unstoppable forces of technological progress and economic logic. As these forces continue to align, the automotive landscape will change beyond recognition, and the age of affordable electric vehicles will become a reality.